So today we're gonna continue with acids and bases. Please do remember to log in and interact with me. By logging on to Hello Smart, you sign up as a guest and you'll be asked to enter a class ID and this for this particular class and all the class we're gonna engage in. That will be 598751 and we interact. So last time we were looking at acids and bases. We defined what an acid is, a base is. We said an acid is a chemical. It's a chemical that when in solution, it will taste sour and it will be high in what? Hydrogen ion, positive hydrogen ions. It will be high in positive hydrogen ions. We call that H+. With acids, it will be high. With bases, it will be low. We have neutralization, and that's when an acid and a base react and they form a product that is neutral. Normally, they will form a salt and water, right? We spoke of properties of these chemicals. We said they are corrosive. They have a chemical formula. They are essential, and they form part of. We can find them in our immune system. We spoke of a pH scale, right? We said a pH scale is a measure of a substance's acidity or how basic it ranges from 0 to 14, where 7 is where it is neutral. Below 7, we know that this is where we find acidic substances. Above 7, that's when we find basic substances, right? We had discussed the range of our commonly used products in our households or homes that identify with acids and bases, that identify with our pH scale. We said acids such as lemons and other fruits, vinegar, citric acid, full acid, have the following properties. We said they are sour, they feel rough on the skin, and they're dangerous because they are corrosive. We discussed bases such as bicarbonate of soda, washing powder, soaps, bleach, as being bitter, as being slippery, dangerous, as they're called, and they're sometimes called alkalines, right? And we said when substances are neither acidic or basic, we know that we call these neutral. We say these substances are neutral when they are neither acidic or basic. Neutral substances include cooking oil, sugar, pure water, and many more, right? So let's look at a short activity. For you to engage with me in this activity, you need to log into hellosmart.com. You sign in as a guest. You enter the class ID as identified earlier in the session, and you can engage with me. So let's start the activity and see. So acids. Let's remove this here. Acids, do they taste sour? True or false? For 100 points. We've already discussed this. Yes, acids will normally taste sour. So this should be correct because acids should taste sour, right? Let's continue and look at more examples. Let's spin the wheel and see. Let's spin the wheel and see. We have all acids are dangerous. All acids are dangerous. Earlier on, we discussed how we can find acids in our households, those that we consume in our households. So if you can consume them in our households, that means they're not so dangerous to us, right? So are all acids dangerous? No, no, they are not, because we find acids such as lemon, acids such as stomach acid, which is very acidic. We have acids such as black coffee. We know that from our table when we're discussing it in our pH scale or pH table. We discussed how it is an acid, but we consume it, so it is not so dangerous. Meaning not all, but some are, of course, but not all. And hence you've answered the question there. Let's spin the wheel and see another spin the wheel. Oh, this is for 2 times the next question is worth more points. Let's go and see. Let's find our question which will be worth 2 times the points. Can we sense 3 tastes with our tongues? We discussed how our tongues can taste various tastes, and we discussed them as sour, bitter, sweet, and what? Salt. It's 4 tastes that our tongues can taste. So can our senses taste? Can our tongues sense 3 tastes? 3 tastes? No, they can sense 4, right? False, because they can sense 4, not 3. And for the 4 being sour, sweet, bitter, and salty. Let's continue and see. We can find out if something is an acid by tasting it. How do we test for it? Remember, we already discussed it. How do we taste? How do we test for acid? By tasting. Testing and tasting are 2 different. You can test by testing, and tasting are 2 different things. Let me not say you can test by tasting. No. We never, as scientists or as humans, test by tasting. We test in the laboratory. And as to whether something is an acid or not, let's remember, how do we test for that? We look at the concentration of hydrogen ions inside. If they are, it will register as an acid. If they are low, it will register as a base. Remember to test acid, because some acids, at the meaning, we cannot be placing our tongues where they do. We can find out if something is an acid by tasting it. No, no, we may not. We cannot. We will never ever test by tasting. Awesome. Let's look at a few more questions. Let's have a few more questions on acids and bases and see. Very important. We never test by tasting. Some acids or some substances, it be an acid, base, it be whatever substance you have, you never test by tasting. You better remember that. Vinegar is a mixture of acetic acid and water. Remember, yes, vinegar is a mix of an acid and a base. Laboratory acids must be handled with care using protective equipment. Laboratory acids, laboratory substances should be handled with care, and you should be having protective gear in order to use them. So very true, but very true. So we know what acids are. We know what bases are, we have what we call indicators. So these are acid-base indicators. It's a strip of paper that changes upon being immersed in the acid or in the base. They identify as to, is this an acid or a base. So some other substances also change color when an acid or a base is added to them. So by changing their color, they show that they have reacted with an acid or a base. So we call these acid-base indicators because upon interacting or reacting with the substance, they will change color and identify as to what this is. The most well-known acid-base indicator is litmus. Litmus being a strip of paper that we use to indicate and immerse it in the acid, our acid or our base, and it will change color and it will identify to us as to whether this is an acid or a base. The most commonly used indicator is litmus, but we have a variety of indicators as to testing whether something is an acid or a base. So this is how we test for acids and bases, by using an indicator to see if something's an acid or something's a base. The one commonly used indicator is the litmus, right? Awesome. So let's have a few more questions to assess our understanding of acids and bases. From this video and the one before this one, covering acids, bases, and indicators, you should be well off to understanding this entire chapter, which is crucial in sciences, which is crucial in matter and materials, especially chemistry. So here's our next activity, small activity, in order to help us understand acids and bases better. We have discussed how acids are chemicals that have high concentrations of hydrogen ions. They can be tested for by using litmus. They are sour in taste and they range below 7, from 0 to below 7 in our pH scale, right? We have bases, which are chemicals when immersed in water will have low concentrations of hydrogen ions, right? When immersed in solution will have low concentrations of hydrogen ions. They are quite slippery, and they can also be tested by using indicators. The most commonly used indicator is litmus. Our tongue can sense, as tongues can sense 4 tastes, being sweet, sour, salty, and bitter. Where sour is normally associated with acidic substances and bitter is normally associated with our basic substance. So once again, for you to interact with me in this activity, you need to log into hellosmart.com, use this class ID 598751, and we interact. So your responses will be able to appear to me and you can interact with me. So the question on the board reads as, the well-known of all acid-base indicators is what? We have options below and we need to fill in the blanks. As we did in the earlier activity, we're going to choose from the list of given words to fill in the blanks that are in our questions. So we have a number of questions and we're going to choose words from below and fill them in. So we have this well-known indicator, acid-base indicator of all of them. And we need to indicate or identify what it's called. We have a substance that can eat away at other substances is called what? We discussed it as when substances are able to eat away, and we know that in our discussion in our lesson we had discussed that and bases have this particular property, and we discussed the property as being able to eat away at materials, degrade other materials. They can break down and deform other materials. So in that, we say that particular property that we give to our acids and bases, because they can do this, they can break away or break down or eat away at substances, as one particular property. We have a number of words we can choose from, fortunately, to remind us, but we don't need reminding because we know this. We know that properties, especially when it comes to acids and bases, they have this particular property in which the one thing that makes them actually dangerous, meaning we cannot just be going around and taste, is because of this particular property, right? It makes them dangerous to interact with. It's the one reason when handling or working with laboratory substances, we need to be wearing our protective, right? It is because of this particular property. The next question is, an acid will do what a base, and vice versa, meaning an acid will do something to a base and a base will do the very same thing to an acid. And we have a range of answers to choose from. That what does an acid do to a base? When a base interacts with an acid, what happens, right? When a base meets an acid, when they react, what happens? So we have substances are neither acidic nor basic. We discussed how we have substances that fall within the topic, but are neither acidic or basic. We know what acids are, we know what bases are, but what happens to substances that are neither acidic or basic, right? Foods that are poisonous often taste how? Foods that are poisonous often taste how? How would you know? How would anyone know? Because poisonous food should be, no, not all poisonous food will kill you, but it will give you some reaction to it, maybe a ranitami or something. By poisonous food, I would like us to think of rotten food, not poisonous per se. We can replace the word poisonous with spoiled or rotten. And how will that food taste? I'm sure you've tasted something that was a bit ripe before, so we'll substitute poisonous with that, but that's what we mean. Once they can give you a reaction like that, it is now poisonous. So let's answer the questions. You log into Hello Smart, use the class ID 598751. You log in your name and we interact. So the first question says, the well-known of all acids and bases indicators is called what? We just discussed it. We said it's litmus paper. It's a strip of paper that will immerse or react with a particular substance, and upon changing color, it will indicate as to whether this is an acid or a base. That's litmus paper. That's litmus paper. So a substance that can eat away at other substances is called what? So a substance that can eat away or degrade or break down other substances, what's that property? What is it doing to it? It's corroding the other substance, you remember? So when thinking of corrosion, think of that metal piece or that scrap metal piece you left outside, and it has hit by rain, it has hit by sunlight, and now it's turning a bit brownish, bronze, and it looks like it's degrading. When you hold it or try to bend it, it's easier than when it used to. It's because it has degraded. It has chemically reacted with a corrosive substrate, and we discussed how acids and bases are corrosive. They react chemically with other substances and they can break them down. We say substances that can break down other substances are corrosive. So an acid will do a base and vice versa, meaning a base will do the same thing to an acid. When you put an acid and a base together, they react, and I have a slide on it that we already discussed, that when an acid and a base meet, what happens? They react to form salt and water. They form a salt and water. And the salt will depend on what acid you're using and what base is, meaning depending on the acid you're using, the base you're using, the particular salt. So let's say you're using an acid such as sodium chloride, right? Sodium chloride is an acid, is a very strong acid, a very corrosive acid, a very dangerous. Let's say you're using sodium chloride as an acid, and the base, let's use hydrogen sulfate, or let's use sodium hydroxide. So I'm going to add a page. Sodium we're reacting an acid, hydrochloric acid, a very strong acid, very corrosive, very dangerous, and we are reacting with a base, sodium hydroxide, this being a base. So when an acid and a base meet, what comes out? We said a salt and water. And what salt comes out of this? It's sodium chloride plus H2O, where this is the salt that comes out and this is the water that comes out. So when an acid and a base react, they form salt and water. And we say this reaction is neutralization. They neutralize each other, either the base neutralizing the acid or the acid neutralizing the base. When an acid and a base meet, they neutralize, right, to form and salt and water. Whatever acid, whatever base, when they meet, they will neutralize to form salt and water. Awesome. Sorry about that. So they will neutralize. An acid will neutralize a base, and a base will neutralize an acid. Why can't we use the word neutral? Because an acid will not neutral a base, right? but it will neutralize a base, and the base will neutralize an acid. We said a well-known substance, a well-known acid-base indicator is litmus. We said a substance that can eat away at other substances is called corrosive. And two substances are neither acids or bases. What we said, when a substance is neither an acid nor a base, we say it is, yes, neutral. Foods that are poisonous and often taste, food that are poisonous will often taste bitter. Let's see. Yes. And those are our answers, right? And once you can interact with me, we can see how you are progressing or understanding our questions. And you will be able to get immediate feedback upon me releasing the answers to you, to say yes, well-known substances or well-known substance that is an indicator for acids and bases is litmus. Substances that eat away at others are said to be corrosive. An acid will neutralize a base. Neutral substances are those that are neither acids or bases. Foods will normally taste bitter, yes, when they are ripe. And that brings us to the end of our. Thank you very much for your interaction. Please remember to log into Hello Smart to interact with me. And remember that these lessons are brought to you by the Department of Basic Education. They are in line with the revised caps for this year, for 2020. And they're also brought to you live by VT Africa Holdings. Thank you.